So again, go back to the layer 6. Here we go. So firstly highlight this one. Let's see where it is connected, and it is kind of easy connections, right? So you can start here and connect like this, right? So you have to just connect those one by one. Select this one. Okay, where it is going. Okay, so again, you don't need to just follow the clearance between those, because we have to length match as well. So just try to place, extra gap between the signals that we are placing. So during the length match, we don't need to adjust the signals later, right? Similarly, select another one. Okay, it's going in that direction. Okay, we'll adjust that later. Okay, let's target another one. So where the next connection is going. Okay, so now here you can see you don't need to blindly follow the same orientation, like, so our design, see, our most important priority is we have to make it working, right? So to do that, I would suggest, instead of routing from there, because here we will face some clearance problem, we can start from here as well. So it is already highlighted, and see, so we have to make this connection. Okay, so for this one we have to adjust these as well. So we have to create some space in this section. Okay, and for this one, okay, so I'm going to place it here, and similarly this one, and adjust this as well. So for that I'm going to place it here, and this one here. Okay, so now we have enough clearance to route this track. Let's make this connection as well. Okay, what next? So next is this one, how it is connected. So let's see. Okay, we have to connect this. So to route this, if I'll follow this path, let's see. Okay, so we don't have space to void this one. Okay, let's see if we make some space in this section as well. I'm going to delete these. So again, you have to just adjust those tracks and just try to place the as short as connection as possible. See, again, I have another way to route this like this, right? But again, this will be the longest one, and either we have to do that later, just do it right now. So let's remove this stub. Okay, let's select another one. Okay, so how it will be routed? So we have one option is I can route like this. If I'll do that, then we have to route these connections as well. Okay, so one solution is we have to drag that on top layer. Okay, and just make it with this one, the shortest connection. Okay, now for these two, what we can do, so here you can see we have enough space to place those connections, right? So let's do that as well. So it will be here, and this is the next one, I guess. Okay, so to route this one, this is the good option. Okay, now adjust those quickly. Okay, so now we have 3 connections more to connect, and one is one is the DQS signal, that is the differential one, and how it will be connected. So this is there, right? So we can connect it from here to this way. Okay, so firstly we have to just correct those whatever the errors we are seeing here. So just remove this one and remove these as well. There's no point to place those. Okay, now let's see. So here you can see we can't able to cross this line. Okay, so there are 2 options. Either we can place the via in this section, and again that will create the problem because of clearance. Another is we can reduce the clearance between the pad and the track for this particular byte group. Okay, so to do that, again, where you will see these kind of problems, like where we have to cross you can say between the 2 pads. Okay, and that problem will occur only with the differential tracks. Okay, so the solution of doing that is, the solution of this problem or this design rule constraint is, we can simply go to our schematic, and for each and every differential pair we will assign the net class, and that net class will be the notation of differential pairs, right? So what we will do, we will basically create a clearance rule which will be our first priority out of all the clearance priorities, and yeah, so there we will reduce the clearance to up to certain extent, because see, differential pair is not follow the clearance, right? It will follow the gap between those that we have defined from the impedance, right? So how to do that? So again, I'm going to do for Lpddr4 first, then later we can assign those for all the differential tracks on the schematic design. So to do that, we'll simply create a net class, firstly place the blanket, and create a separate net class for all the differential nets. And I'm going to rename that with differential pair class, and just copy this, create a net class here, enter. Okay, and where else you can see the differential pairs? It is for the clock as well, right? So there also we'll place the blanket first. So you people got this, right? Why I'm doing this one? Because we have to see, instead of creating a generalized rule of clearance can create a problem, right? Because that clearance will be the minimum clearance for all the tracks, all the pads and everything, right? But we know that as a designer, okay, this is the problem. So again, this is not the problem if we can pass those differential track between the ground and this one, right? So we know that, right? So we can't, instead of making it a generalized design rule, we're going to assign that for the differential pairs only. Okay, so that is what I'm doing here. And just copy the net class from this one, place it here. Similarly we'll do for this as well. and for this clock. Okay, perfect. Now save this and import all the changes on the PCB file. Design, import, execute changes. Okay, now go to the design rules, and here we have to add one more new clearance, and that is the diff clearance. And this is our priority one. Okay, this is first priority rule for all the clearance, right? So again, I'm going with 0.1 and we'll see if it will work or not. Then we'll later reduce this one. So to make it or to change the priority, firstly apply this and go to the net, select the net class that we have declared, and that is net class, and this is the differential one, right? Here we go, differential pair class, then apply. Now go to the clearance. Here you can see the priorities, right? So as you can see, the differential pair class, okay, clearance class has first priority. Okay, apply those, and if it is not one, you can make it one. Okay, so now we can able to route those, and if we can't able to route those, we'll measure the clearance and we'll reduce it further for the differential net only. Okay, we have to see that. So let's check the DRC. Okay, so now we can remove those connections and try it again. Go to a differential. Okay, so as you can see, you can kind of able to route those connections from here, right? So this is what I wanted. Now here we're going to place few pair of VRs. Okay, hold on. Okay, now for differential pair, what is the best way to place VRs? So there are again you can go through different documentation for differential pairs and everything, and there you'll find the best way to place the VRs for differential is this one. So just copy this, and one will be like this, one will be like this, right? And here we're going to place the VR like this, right? Now we can go for this one. So here, so again, this is one more thing to placing. Hold on. So here we have few more tracks under those. Okay, now it's removed. So how we can place these? Just arrange those like that. So it will be, again, you'll kind of make them closer more than the design constraint. It will create the issue, right? So okay, I forgot to add some copper under those track as well. Now what you have to do, select the bottom layer, select the differential one and connect those, right? Hold on. Now what next? We have to just make the connections, and you can see what is the way to connect those. So it will be like this. So for routing these one, we're going to follow this way. Okay, so again, here is the problem, right? So the thing is, why this one is problem? Because it is crossing the line that we have placed here. So now in case of this byte group, when we're going to place the via for the fan out, those via will be kind of shorting, or there will be connection short between this layer and the via, right? So we can't able to place via in this section. So to adjust that, that's why I place this one. So you can see we can able to visualize the problem which will be coming in near future when we're going to route this byte group, right? So now this is fine. I guess we have one more connection to route. This is for this byte group, and this for data mask. Okay, so we have this on the top layer as well. So let's adjust that, and this as well. So from here, there we can able to create the space, right? Okay, so how this will be routed? So it will be coming from here to here. Okay, then we can connect this one. So let's route this as well. Okay, so again, these are like very easy connections here. The problem you'll see when we'll be routing these byte groups. Again, we can go for another byte group. So let's again go to the PCB, select the second one. Okay, so for second one, what is our plan? Okay, same problem is coming here. So to avoid that, we'll route this here. Okay, so now it is fine here. So these markers are very important, and just if you want, you can try with these markers and you will see what is the problem here. Anyways, so for byte group, we have decided we're going to route that on layer 3, which is this one. Okay, so why I've selected layer 3 here instead of layer 2? Because see, all those connections are kind of crossing each other. There will be you'll see that we can't able to avoid the the parallelness, or the tracks which is coming under the track on the adjacent layer, right? So to avoid these kind of problems, again, those also can cause clearance issues, right? Because those layers are the gap between those, the dielectric thickness is very small, right? So to avoid these problems, we're going to route we're going to leave one layer between those, and we're going to use the L3 here, right? So let's do that. So for that one, we have to again create the template for the connections, and we know that how to do it. So firstly, we'll place a via between those. Okay, now we'll assign the net. Let's make the connection between those, and firstly we're going to use top layer. Now, which is another layer that we'll use, this is L3, and route it here. Now select these three, Control C, and this will be our template for this byte group. Okay, so here we are seeing another issue, which is the width. Okay, so you remember when we started the placement, okay, when we started the layout of this center section, we have defined the width of the track, right? The minimum, maximum. You can see I've written those on the div. Okay, so I guess I didn't. Okay, so I guess I've covered that on day 10. I remember that. So again, if you open the design rule one more time, and here on the width, which is the generalized width that we have defined, and okay, hold on, let's change it to mil. Design rules width. you can see the minimum width that we have defined is 3 mil, right? But in this case, the track width of this layer 3, which is around 1.9 mil, right? So we're going to reduce that, and in mm I've already noted down it is 0.05 mm, and apply this. So this error constraint will be removed. Let's execute that DRC. So this is the last change as per the design rule. So for routing of all the Lpddr4 connections, these are the all the design rules that we needed. Yeah, when we will be doing the length matching, there will be few more that we'll see. Okay, so now it's fine. So let's select this and just, so now for these connections, look how all the things are going here, the tracks orientation. So you can see this is going from this to this way, right? Like this. So we're going to follow this orientation, and later if required we can change that orientation as per the requirement. So let's place those quickly. Yeah, any doubt? Okay, so if you don't have doubt, could you please mute? Okay, let's place for this as well. And here we can see the problem of those differential track width, right? So we'll remove that later. Okay, similarly we'll create the template for this the bottom layer component, and we'll follow the same way. So firstly place the via between those, and double click on this, copy the net name, double click on this one, paste it, connect the bottom layer connection. Okay, hold on. So just make it straight. Okay, now change the layer to L3. So double click on this one. Yeah, I forgot to add the template. So this is from 12 to 8, I guess, right? Sorry, 12 to 10. Okay, so as you can see, this via group is not here. So we have to define that via on the layer stack manager, as we already did. So go to the layer stack manager one more time, and I'm going to note that as well. So we have to add the via type for 12 to 10, okay, or 10 to 12, vice versa. Go to the via types. So add one more via. Go to the properties. So that is coming from 12 to 10, right? Just verify if it is not defined. Okay. Okay, first to 10 is also not defined, as you can see on the screen, right? So we'll do that as well. So add one more via, properties, go to, so this will be the top layer, this will be the L3. Okay, now save it. Go to the PCB file. Okay, so now we can double click on this one and just change this property to 12 to 10, right? Where it is, this one. Okay, similarly for these I've assigned all the through-holes. Just select those quickly. Forgot to add via type here, so we can assign those together as well. So from here, this is coming from 1 to 10. Okay, that's it. Now we can copy this. Okay, before that Just route the track on the 10th layer. Okay, copy this, Control C, and this will be our another template for bottom layer. Now, so see, again, we're going to follow this same orientation. So track will be coming like this, and it will be connected on this one. Okay. So let's place those quickly. And start the layout. So for this one, just start. So again, you have two options to select, like how to start the layout for this thing. So either you can, start from this one and, start making connections. So if you'll see, when we'll start from this one, the connection is kind of random. Like first pin is here, second is here, like that. But when we start from this, we know that, okay, at least one side has a pattern, right? So you can start from this.